Okay, ladies, gentlemen, everyone, welcome back to another week of EECS 404 Game Engine Architecture. I always love to watch the AutoGrader status dashboard as we're coming into a deadline, and sometimes we see some engines, some submissions coming in hot. I think we got a few people through in the last 5 minutes or so. A reminder, okay, if you missed it, if you haven't gotten everything in, you're okay. You're okay, especially if you got a couple of the platforms in, but maybe you haven't finished Mac, or maybe you haven't finished Linux. And you're going to get 20% off now for every homework 3 that you submit. Okay, 20% off, but that might not be that much if you got the rest of the points on the other platforms. In any case, 80% of your grade is way better than 0%, okay? So make sure if you didn't get this done that you eventually kind of come back and knock it out. Ideally pretty quickly, because the better you do on this homework, the easier next homework is going to be. All right? Got a question in the back.
Yeah. If you submit like 429 and then the grader grades it like 4.
Yeah. Is it late or not? Yeah. Okay, so if you submit at 429, you submitted on time, but it's going to be graded late. And this actually would make a really good quiz question. I don't think it is one. But for security reasons, because you can actually alter and change the timestamp associated with your commits within Git. So for security reasons, it's when the AutoGrader finishes grading you. So you really want to try and get these things in by like 425 or so. It depends on the load, how many people you have in front of you. For the MMO architecture course that I'm currently iterating on and experimenting with, the design of the AutoGrader is different. When you request an AutoGrade, the AutoGrader knows exactly what you want to have graded, but also we spin up a Fargate container, like a Docker container, with the AutoGrader to grade you when you request it. So there's no queue, which should make any bottlenecks that come up not really a thing. It's pretty neat. It means also that I only have to pay money when people request grading and not just have an AutoGrader running 24/7 around the clock like we do in this course. So anyway, it's kind of neat. Anyway, we have a lot of things to do today. We are finishing up your homework 3. We're launching homework 4, which I think is actually kind of a fun homework. It's not too bad because you actually don't have... I think you have one new dependency, rapid JSON, that you have to integrate, and it's an easy peasy one. It is very similar to integrating GLM, which you got experience with this week. And you're just writing a lot of additional logic. You are optimizing that logic a little bit more than you had to optimize this week. And I think it's going to be a good time. I know it's not too burdensome because I think it was... if this person wants to chime in and claim the credit, they could tell me exactly when. But I think as of like Friday, we had someone grab 100% on homework 4. And that actually caused me to say, enough is enough. This person's out of control. And I updated the AutoGraders, so it's not actually possible to submit for an assignment unless it's open on Canvas now. Okay, so please, the reason we do that, we know you want to run ahead, and I really respect that. I think that's pretty cool. But there's a reason we kind of pace the course out like it is. We really want to help you avoid burnout. And we also want to make sure that you are receiving relevant lectures as you're doing the relevant homework, right? So it's a little bit of a weird mismatch. If you do the homework and then you start receiving the lecture content that's supposed to help you appreciate what you're doing a little bit more, provide a bit more context. In any case, if you feel the hankering to go ahead of the course, to sprint ahead, like we got a really good group. I think this is actually a crazy good group. Maybe our best ever of game engine architecture students. Like a lot of you are cracked in this course. If you want to sprint ahead, I would encourage you to experiment with other game engines that already exist to develop your knowledge of what engines are out there, or maybe create a new repo and start adding some of your own custom features, have some fun with that. Or, and this is my favorite suggestion for what to do, go enjoy your life, okay? And take a step away from programming and game dev, okay? Have you ever heard this phrase, distance makes the heart grow fonder? All right, if you give yourself some breathing room from game dev, that will only make you crave it more, which is what you want when the hard assignments arrive. I will tell you, I used to love games a lot more than I currently do. I have to deal with games all day, every day, sometimes for like 9 hours of lecturing, like today. And I could say, when I get home, say games were a mistake, okay? And but then if I take some time to take a break from them, I start to love them again. So don't let that burnout affect you. That is all that I am saying. Okay, we got a game engine of the day. For all of you nerds, this is a really cool one because this is an open source engine, and it's a very famous open source engine. I think many people are surprised to learn it was open sourced. But this is ID Tech 1. This is the Doom engine, and you can kind of see an example of it right down here. The tried and true Doom engine. It was absolutely famous for ushering in the era, the dominance, the reign of terror of the first-person shooter genre, which still cannot be dethroned even today. And Doom was really the... So there wasn't really, I don't think there was a first-person shooter genre for quite a while. Instead, they didn't call it first-person shooter genre, they called them Doom clones, because every game coming out after Doom looked like Doom. It had similar rendering to Doom, similar gameplay to Doom, and it wasn't until the genre kind of evolved that it was recognized as a genre. This engine right here is quite a crazy engine, and one thing you might not realize about it, just playing through it, the environments look and feel 3D. They are full of secrets and passageways. In actuality, though, if you look at the tools that are used, look at this. This is the Doom editor. I believe this is a screenshot of the kind of tools that John Carmack and John Romero and team were using to make Doom content. And the actual maps look 3D, but in reality, most of the gameplay is 2D. And you actually define and create your map in terms of 2D maps like this. And I think there's some layering you can do to kind of get that 3D effect. But most of the engine is actually 2D. A lot of its calculations, like for collision detection, is 2D. I kid you not, in the Doom engine, in many of the Doom ports, if you have, imagine there's a killer monkey with a gun. Right up there on that light above me, okay? Right up there on that light. I can literally be shooting straight forward underneath the monkey with the gun. And when I pull the trigger, the monkey is going to take damage, even if I'm shooting way below it. And I believe that's because the collision detection is really, genuinely not 3D. It is kind of 2D. It's a 2D raycast that occurs. And so there are all these little hints that the engine is actually kind of 2D under the hood, even though it renders in this kind of really retro, nice, beautiful 3D. But anyway, the GitHub repository is available. I have never had success getting this thing to build, despite John Carmack saying that this was made in portable C++. I've never gotten this thing to build, and I've tried a number of times. Maybe I just stink at it. Maybe I'm not as good at coaxing the C++ compilers to do what I want as I think I am. But who knows? I do feel like something is missing from this repo, maybe. There is a free ebook on the... Oh, okay, well, my link has died during it. But there is a free ebook online. I'm guessing it just moved to a new location on the server. You can Google it if you want to. Fabian, it looks like, is going to provide this to us. Yeah, here we go. So it might be in here somewhere. But there's an ebook that has a lot of really great interviews and historical context for why the engine was the way that it was, and also how it was built. In particular, when I was reading it a couple of years ago, this quote really resonated with me. It's a big theme of this course, actually. Okay? John said, there are often trade-offs that you can make that get you a crazy advantage in terms of maybe performance, in exchange for some limitations that you might be able to design around. For instance, pretty soon when we get to homework 5, homework 6 is the crazy hard collision detection homework. It's not that crazy hard, but it is a big collision detection homework. When you get to that homework, you're going to realize that if only we could tell our level designers, you are required to have colliders no bigger than this size. Suddenly, you can optimize collision detection like crazy. But if you have a very general purpose game engine that can't enforce that limitation, like Unity cannot enforce a limitation that says, hey, game designer, your box colliders can only be this big, right? If you can enforce those kind of limitations, which requires a contract between the game engine team and the game design team, then you can get crazy performance benefits. By the way, this is another good reason for you to make your own custom engine, right? If you are Sucker Punch and you have to have the most gorgeous game running on the PlayStation 4, which is dirt cheap, crappy old hardware, believe it or not. I mean, there's a reason it's like only $300, $400 to buy a PlayStation 4, okay? Like, that's way less expensive than the GPU I bought for my recent computer build, all right? Holy cannoli. If you can enforce limitations, if Sucker Punch can say, hey, we're going to build this engine, it's going to be for this game, and this game is banned from doing this kind of collision detection, then they can get crazy performance, all right? Anyway, but the thing is, these off-the-shelf engines are almost never what you choose if you need performance, okay? The personal custom-built proprietary game engines are almost always optimizing for runtime performance, and the off-the-shelf engines like Unity, Unreal, right, user-friendly, very user-friendly engines, they're optimizing not for runtime performance, but for dev time performance. They want to make you help you build a game quickly, but you might be building like an itch.io game. Those games are amazing. I love those games. Some of my favorites in the world. They don't look that pretty. They don't have 1,000 billion enemies going on, but they are made very quickly, which means they can be full of unique, novel ideas, which is what really matters. I think what really matters these days is not that you have 1,000 enemies in your game, but that those enemies are extremely unique and full of character and surprises. Anyway, that's the end of my rant here. This is all to say that when I tell you things in this course, often it's coming not only from my own experiences, but from the things that I've gotten from very professional devs. I am not a game engine engineer. I'm a gameplay engineer by trade, okay? But I mean, you won't find many game engine engineers teaching classes these days. So I'm the best you got. I'm sorry. Okay, hopefully that's not too bad. Okay, you can watch a video recreation of the Doom engine here, which is a really kind of awesome tutorial series on you kind of building your own kind of Doom-style ray-traced engine, or line-traced engine, raycast engine, from scratch. And I think they do that in C or C++ here. They go through some of the math into how this works, and you really get a feel for why this kind of is a fake 3D engine. It is 2D under the hood in many aspects, and it's good stuff. The kind of computers this engine had to run on at the time were like these computers. I don't know exactly the hardware specs, but I know they're not very good. They are meant for like displaying graphs, okay? Like TOPS. That's the fancy multimedia stuff they were capable of, needing to run a fast-paced, real-time, first-person game. A quick thing I recall, Gabe Newell. Okay, why do we know Gabe Newell? Anyone?
Isn't he one of the co-founders of Steam, something like that?
Exactly. Yep, Steam. Okay. Hallowed be thy name, Newell. And the creator of Steam, Valve, right? Gabe Newell, if I recall, came from Microsoft. I think he was an engineer or maybe a producer, a product lead at Microsoft. And he told, so in an interview, I think he said that one of the reasons he wanted to create Valve, create Half-Life, and then go create Steam was that he was looking at statistics on like what programs computers had on them. Then he saw something crazy, like a ton of computers had Windows, as you'd expect. Windows was everywhere on computers at the time, but Doom was actually more popular than Windows, the operating system. More computers had Doom than had Windows. It kind of just spoke to him the power of this new interactive medium. And so he wanted in on it, and he did all right. He did not too bad. So anyway, one interesting thing as well about this is that it used integer math extensively. Integer math is very interesting because it's actually usually a bit slower than floating point math, but it is more precise than floating point math. And also in that era, a lot of these machines didn't actually have support for floating point yet, I think. And so integer mathematics was how you could kind of represent fractional numbers without floating point hardware. So kind of interesting. If you need determinism in your game engine, some game engines have integer math modes to make it kind of easier to maintain that determinism. Floating point stuff gets really funky really fast, and it can be hard to maintain determinism, which you need, for instance, for perfect replay features. And so, integer mathematics can sometimes come into play. Okay, sweet. And we do have the stream rolling, rock and roll. Something you should know, the IGDA Ann Arbor, our first one of the semesters happening this Thursday, this is an opportunity for extra credit. We have Sean Pride of Warner Brothers Games coming to Ann Arbor, going to talk about NPCs and traditional game AI and how they kind of manage that style of content at Warner Brothers. And if you see this big, nasty-looking Spartan logo right here, oh, I can't believe it, right? Who let this on here? It's because Sean is a alum of the, unfortunately, very fantastic Michigan State University game dev program. They've got a great grad program as well. If you want to go to grad school and want more time to do game dev stuff, especially if you get those in-state tuition rates, not a bad choice, Michigan State University for grad school. Anyway, so if you come to that, you'll get free pizza. You'll get a nice lecture by an industry veteran. You can ask whatever questions you want. You take a selfie, you upload it to Canvas, you get some extra credit. Why? There's really kind of no better way to... there's a lot of soft things about game dev that you won't get just by hanging out in your IDE programming, okay? You got to get out there. You want to talk to people. You want to network, and you'll learn a lot of stuff, I guarantee it, okay? Actually, the amount of extra credit I'm going to give you for these events probably isn't enough, okay, to fully represent the knowledge gain you're getting by going to events like this. Speaking of immersing yourself in an ecosystem, how did Homework 3 go? Went okay? There was like an interesting kind of bifurcation that I saw in the evals. Like half the students were like, yeah, this is not too bad. AutoGrader seems nice. I'm glad I've got that figured out now. And the other half, the feedback was like, to hell with Xcode. Okay, Mac is evil. All right. And what it seemed like to me was if you have had some experience with the Macintosh operating system, you had a pretty nice time. And if you didn't have any experience with a Mac, a surprising number of students had never used a Mac before in their life somehow. And there's no problem if that describes you. But that definitely is going to make for a bit of a rougher time on this first assignment. The good news is that you now have experience on Mac and with Xcode. Okay, and this is definitely the kind of thing where it's kind of an eat your vegetables kind of thing. It might not taste good, it might not be pleasant, but it is important for you. It is important for you to spend time where your users are. Okay, you need to go hang out in the Mac operating system. You need to get used to its UI, its general kind of flavor of doing things. Xcode may not be everyone's favorite program, but you will need to use it. There's a decent chance that you graduate and you end up in a Mac shop or an iOS shop, and you are interacting with Xcode every day. Why? Because that's what your users use. So you have to use it, and you have to know it, and you might not like it, but you need to know it. You need to understand it. And so I hope that as time goes on, you will start to feel this as kind of a useful, powerful thing. It's not exactly pleasant, but you might get to a team where you are the master. You are the most senior person in a certain IDE. And that's going to be a very, very powerful thing. I recall, and I don't know if I shared the story yet, but I recall when I was at Electronic Arts, there was one guy on our central technology team who was a god at Visual Studio compiler issues. And everyone was going to this guy to get their compiler issues solved. And this kind of created a bit of a dependency. It's like, wow, like this person, like we can't lose this person, okay? Like if we lose this person, if this person gets hired away, like the whole project is doomed, right? Because no one else can figure out these really nasty, weird compiler issues. You want to be that person on your team. It's good job security. It makes you very senior very quickly if you have rare knowledge that only you have that people depend upon. And you only get this knowledge by going through and dealing with the unpleasant muck that is, Mac or Visual Studio or whatever, particular situation you're in. I sometimes see courses, online courses, help guides, presentations that leave a really bad taste in my mouth. You know why? Because they give you the impression that you can learn Unreal Engine without spending a shit ton of time in Unreal Engine, okay? If you want to learn these things, you need to be there. You need to be in the trenches. You need to grind it out, okay? I didn't grind out like 100 hours of Blender, all right, for fun. Blender is great, but I was not going to be able to teach this EECS 298 Blender course unless I was in there smashing my face against it for a very painful amount of time. All right. And I did it, and now I can teach the course, and now it takes the students less time of bashing their faces in, but it still takes some time, okay? Like, you have to get in there, you have to do the thing, and there's no way around this. Anyone who's trying to tell you another way around this is selling snake oil. And no, I'm not yelling at the people who are using Premake. I think it's awesome that you learn something like Premake. But, if you end up at a Mac shop, you might wish that you had spent a little bit more time learning the Xcode interface. And when we get to linking and libraries and stuff like that, Premake might fall a little bit short for you. Who knows? You might need to get in there anyway. If you don't know what Premake is, you're like, what are you talking about this, Austin? Some students hate Xcode so much that they're going out of their way to learn really cool stuff that I'm super happy they're learning. But it's just the power of Xcode anger. It's really amazing. Anyway, Premake is a tool where you will specify things like what libraries do you want, what header paths do you need, what compilation, what optimization level do you want to use. These are very general things that Visual Studio needs to know from you, Make needs to know from you, Linux, and Xcode needs to know from you. And this Premake tool, which is a rival to CMake, by the way, which we will kind of teach you toward the end of the course, will generate the Xcode project file, will generate the Make file for you, will generate the Visual Studio project file for you, and then you can just kind of double-click them, and it opens up, and it works, right? And it has all this setup you need. You don't have to go through the nasty UI, all right? Anyway, that's a quick little spiel. I'm going to stop ranting so we can actually make some progress here. The Get a Job Guide, okay, is here for you. This was put together with the help of some local studio HR team members. So, I mean, this is literally, from the horse's mouth. This is exactly what they're going to do. I kid you not. Would you believe me if I said that a lot of applications, literally, like, they see your resume, you know what they do? Control F. If their team is looking for Unreal people, they write Unreal. And if Unreal is a hit on your resume, like if it shows up, one match, then your resume sticks around a bit longer. If it 0 matches, it gets thrown away. That's how many applications people are seeing. It is crazy. The good news is that if our students get through the early vetting process, they clean up in the interviews because no other students have game engines. That's ridiculous, right? But it can literally be that fragile, okay, that brittle. You want to make sure you're doing some of these techniques, like make sure you're listing on your resume the skills you've got. Blueprints, C#, SDL, Unity, C++, Wise for audio stuff, right? Jira. I've had students tell me like the reason they got the job was like I had Jira on my resume, and that's kind of rare for students. I'm sure a lot of students do know Jira, but they forgot to put it on their resume, and so they didn't get the interview, and that's just how it goes. I don't want that to happen to you, so anyway, read through this guide and try and incorporate its advice if you can. Maybe you can't get all of it. See if there are any ideas in here that resonate with you, and see if you can make use of it. There are some studios that hire a lot of our UMich Wolverines, so you might consider applying to them in particular. There are academic labs and opportunities. There are a lot of labs that love to hire our students because they really do have very good concrete skills. They can actually get into the trenches and make things, which makes you very valuable. If you, a lot of my kind of rock star students, if the job market's really hard, and it has been pretty hard, Blizzard gets 1 billion applications, but how many applications does Dr. Missile's laboratory get? 3? 4? And you're going to annihilate them. Come on, okay? So remember, everyone wants to go and work at their dream job right out of college. Very few people actually do that. What's most important is you get something out of college that can keep your skills growing and get your finances more comfy to give you options. Okay? So go and try and look for some of those kind of game dev adjacent opportunities. They can be really great, actually. Game dev can be a tough business. It can also be an amazing business. Depends on what studio you end up with. Don't neglect some of these other opportunities, particularly if you need internships, because these laboratories can be really good first or second internships, and then you can go get that Google or Blizzard or EA internship some other time, okay, next summer. Anyway, all right, it is there for you. We put in a lot of effort. We hope you'll use it, okay? Okay, all right, and just make sure you talk about your game engine, like, in your interview. I've got it on good word that a lot of students, like, won their interview because they had a game engine they could talk all day about. And, very soon, your repo is going to start to resemble an actual game engine. So you can start to talk about it very seriously soon. Okay, when you're developing your homeworks, be careful about premature optimization. It is sometimes said that it is the root of all evil. When you make code more efficient, you're often using techniques and tricks that make your code harder to understand. And so you want to be very careful about that. You don't have teams in this course, but you have yourself. And sometimes I look at code that's a week old and I'm like, what on earth was I thinking? Okay? And so be careful. Usually, you want to optimize for readability and maintainability, and then when you run into performance problems, then you optimize. And that's, I think, a good rule of thumb here. As an engine developer, you always want to make your code faster because that will free up your game designers who are using your engine to be more ambitious, to do greater things because everything is suddenly running faster. But do be careful about optimizing before you've achieved correctness. Correctness is super useful because once you've achieved it, you now have a test suite where you can push to the autograder and you can learn if you accidentally broke something with your optimizations. It's very common to accidentally optimize so hard that you actually break something or introduce a bug. So, okay, anyway. All right, homework 3, blah, 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 blah. All right, Yeah, don't put all of your code into one file, okay? That's bad business. If you put all your code into one file, you're hanging out with Yandere Dev, okay? Don't do that. If you don't know who I'm talking about, good for you. All right, let's talk about homework 4. Okay. Homework 4, I like homework 4 more than homework 3. It is when things start to feel a lot more engine-y. Last week you made an EECS 281 style, kind of hard-coded game. And this is not EECS 281. That's a great class, but you've already done that class. So, why are we here? Last week you had a very hard-coded set of actors, and you could add additional actors to the game. How would you do it?
Just add it to the vector.
Yeah, in maphelper.h, you had a big list of actors, and it's kind of readable, right? You can add that and customize that. You can customize that array as a dev. Who can't customize that? And this is a big problem. You can't customize that if you are a... This code doesn't get delivered to the user. The player doesn't get to see this code. What do they get? Bingo, they get 1s and 0s, okay? They can't edit this. You can edit this, but you're the dev. The user can't add new characters. They can't easily add new content. If people love your game enough, they will reverse engineer it to the point where they can edit it and add content. That happened to Super Smash Bros. Melee, which was really cool. Nintendo, I don't think, provided any support to the modding community on that one. Well, just hacked it, basically. But this is hard-coded content, all right? And hard-coded content is just not what you tend to see in actual game engines. This is very classic, right? You are putting content into the code itself. Often you want to separate that. A reminder, the end users, your players, are only going to get this in the form of 0s and 1s. They're going to get this in the form of a compiled binary. Even if you distribute the source code, your users might not have a compiler. They might have the wrong compiler. Maybe their compiler that they can find is too new, so it doesn't really work as well with the old source code. Maybe if you give them the source code, well, they have the compiler to compile their changes, but they don't have the knowledge to do so. They have to go take a computer science intro course before they can do anything. They're not going to do that, all right? That stinks. This week, our content will be ripped out, extracted from the actual source code, and it's going to be externalized into a nice human-readable format that anyone can open with a simple text editor, okay? It's going to be JSON. And you can kind of see what's going on here. It's kind of a one-to-one mapping, not quite. But we have over here the hard-coded content for each actor, and then each actor in here is a JSON object. It's a JSON object, and we can have as many of these as we want. And our game engine is going to load that JSON file dynamically at runtime, and we're going to have a totally new adventure. Okay, same genre, but new characters and new environments and new intro, new setting, new character, new plot, and stuff like that. The end users are going to see human-readable format, and what we call this is modability. We don't really call this an engine yet. Maybe you could, but this is really making our game moddable. People love our game. We're going to externalize its assets, and as a result, our game becomes a moddable game. Why bother? Well, we want to provide as much freedom as we can to end users, all right? Mods, in many cases, are what keep games alive, especially single-player games, for a much longer time. After someone has beaten Resident Evil 2 Remake, a fantastic game, they're like, oh, I love this game. I love its mechanics, its technology, its vibe. I wish I had more content. Well, the developers can create more content, or the users, the players, can create more content if the game is moddable. In particular, we have Thomas the Tank Engine staring down the barrel of a rifle here. Has anyone heard of it's a really obscure indie game called Skyrim? Okay, anyone heard of Skyrim, right? Well, Skyrim, if you don't know, has a bit of a modding scene. Okay, look at this. Skyrim SE Mods, an intro for absolute dummies. Beginner's guide, modding Skyrim. Okay, there are entire websites dedicated to teaching you how to mod Skyrim, and there are websites that have like databases full of mods you can download like Nexus Mods, I think is one. They have tons of new adventures and characters and upgrades, graphics, but new quests and stuff like that. This is also a very necessary step on the path to full expressiveness. First you make a game, and then you make that game moddable. But then the more things you make moddable, the more it starts to resemble a general purpose game engine that can do anything. This week, we are making some things moddable, but you are still restricted to this kind of 2D adventure game grid-based format. You're going to change that over time because eventually we don't want to be stuck to this kind of grid-based text adventure format. We want to be able to make a real-time, action-packed, side-scrolling shoot-'em-up if we want to. But maybe we also want to make a top-down racing game. Technically, you can make a 3D game with this engine. Once we've implemented a few more features from Homework 7. Now, it's a pain in the butt to do that, but you can do it officially. I'm waiting for a student to try it. I've been thinking about adding a test case that does that, but I can't. I'm too lazy to write it myself. I have to write every test case in Lua. It's a big pain in the butt. Anyway, all right. So this is going to be customizable. We're going to be able to customize the end user. The player is going to be able to go into this JSON they're going to find, and they're going to be able to customize actor positions, visuals. So what character is every character, as every NPC going to look like? Some will look like Z, some will look like a W, right? Some will be a G. Will they be blocking or not? What kind of motion will they have? What kind of dialogue? What kind of things will they say? What will the story be? Intro and outro messages, stuff like that. We are still stuck in the same genre, but things are loosening up, all right? It's going to start to feel more like an engine. The logic, in particular, is not customizable. For that, in Homework 7, we're going to introduce the Lua programming language atop our C++. Best homework in the course. I hope you enjoy that one. But we are moving from this to stuff like this. This is, I think, the final test case. It has something like 1 million actors all running around in different directions, doing collisions, and you have to try and make this fast. It's not that hard to make this fast, but there's more pressure on your code base to scale well. Okay? On Homework 3, all the test cases are so small, it doesn't really matter if you're scaling well. Here, if you've been a little bit clumsy, you're going to feel it on Homework 4. But it's still not that hard of a homework. I think you're going to enjoy it. And some tips. You definitely should start early on this one. This is what we're going to tell you every time, but we're more serious this time. This week, you have some semi-difficult performance test cases, not like Homework 3. Right, you already saw them up here. They can be a little bit spooky. RapidJSON is another library you'll need to implement. This is a library that allows your C++ code to kind of more easily digest JSON and parse it and mess with it. It was created by Tencent, and it is used in a lot of their mobile games. Tencent has a ton of mobile games that need to parse lots of JSON very quickly. RapidJSON is another header-only library, so they're only headers we care about. We don't care about binaries. We don't have to link anything. There are no DLLs, no static libraries either. We only need a small subset of the RapidJSON features, and the homework spec will have some example code you can use, but you can also ask AI if you want to learn more about RapidJSON and how it works. There's also documentation online if you want to. Okay? Again, the chain of help, right? Try and solve it yourself, but I think you're all getting this. Go to Discord, ask questions, come to office hours. We have a lot of office hours. Oh my goodness, last night we had a ton of people. Wait a second, hold on, let me show you this real quick. Have you seen this? We almost ran out of room on the whiteboard. I have to turn it around so we have more room for tonight's office hours, okay? In fact, that's another thing. Like, in general, I try and do the in-person office hours and focus on in-person, and I try, and after a few in-person, I'll hop online to see if anyone's there. But if you want, like, guaranteed office hour time with me, you probably want to try and come in person if you can. It also tends to go a bit better and a bit faster as well, because I can really get into your computer and I can kind of look at things very closely instead of just ordering you to click on things slowly. Yeah, attend office hours if you can. This is a good environment to work in as well. When everyone else is working around you, it's much easier to get the morale to put in the work and get things knocked out. And yeah, again, you are allowed to help each other. I just don't want you copying each other's code. So if you've got Xcode or Visual Studio issues and you want to help your friend, kind of help them understand what's going on, do it. Okay, no problem with that at all. Okay, any questions? All right. The autograders haven't really crashed. I saw it looked like the Linux autograder was looping. Was like boot looping last night. That's the only issue I saw. I restarted it and it was fine. Linux operating system loves to kill my autograder process when a student process is consuming a lot of resources. I'm not sure how to deal with this yet. Linux operating system just decides you die now. Boom, it's dead. You killed the wrong process. Kill the student process, not my autograder process. And then it kills my autograder process. All right, anyway. Ask me questions about the autograder situation. I've got a lot of very fun stories. One of my favorites was in our first year of running this course. We learned a lot about the Windows operating system. As it turns out, if you have a Windows box and it's an autograder, you're like, oh, well, okay, it's autograding, right? So I'm going to unplug the HDMI cable, right? It doesn't need any video output. No. If you unplug, if Windows, it turns out, Mac doesn't do this and Linux doesn't do this, but Windows, if Windows detects that it has no kind of output display that it needs to send data to, like you unplug the HDMI cable, the video cable, Windows will basically take all rendering and it will slow it down to like a crazy 1 frame per second kind of choke. And that means that if you got SDL code running that's rendering to a screen and trying to like render a bitmap for autograding, you've got a game engine being autograded, suddenly is running and taking like an hour to finish one test case. Okay? And so what do? We have some dummy HDMI plugs that we bought that fake a screen. It's an HDMI dummy plug. You put it into the back of HDMI and it tricks Windows into thinking it's plugged into a TV. So there you go, right? Ask me about more of these because I got a lot more. Windows is very picky and so is Linux. Interestingly, Mac kind of caused the fewest problems. They've got some interesting security and signing related stuff where you like clone down an executable in some libraries and Mac freaks out because it's not like officially from Apple or something. Anyway, okay, let's keep going. Today, I want to talk about one of my favorite classes of bugs, and this is pointer invalidation and kind of memory corruption. And you are going to find yourselves using pointers in this course quite a bit. Maybe in 281, you're kind of able to get away with using them only kind of rarely and on occasion. In this course, you're really going to want to use them quite often, and I'll explain why. all right? One dilemma that you're going to run into quite often in this course is you're going to have kind of this database of objects that are really important. Okay, for instance, last week you had this array called hard-coded actors. And this was an array of actors, and it's these objects. You've got Spartans walking around, you have players, the objects are updating their data, they're moving, all this good stuff. This week, you're going to start to want to accelerate some of your operations. Looking things up. You might want to sort your actor by its name. You might want to start placing these actors in certain locations by their position, so you can look up where they are very quickly. Okay? You also just have no idea generally like who is going to be in this array because you're loading it dynamically at runtime, and the user can mess with it if they want to, right? So you have your player right there. How you store actors is going to become a bit more interesting. So you might want to store them in a certain order for rendering purposes or for collision detection purposes. You might want to break them into groups. But one problem you're going to run into, right, is where you store these objects matter, and you want to be very careful not to have them in multiple places. Do you know what DRY stands for? DRY, don't repeat yourself? In just a few moments, I'm going to kind of explain what that means. It's a very important principle. But you're also going to be thinking about where my objects are in terms of, are they in a contiguous location in memory, which means very efficient to load them into cache and then use them in cache, fewer cache misses, or are they scattered all over the heap, right? Have you ever used the new keyword to put something on the heap, right? The heap is a very big kind of location in memory. You're not going to run out of it, at least not for a long time. But when you use the keyword new, your operating system is going to give you a location on the heap that's kind of scattered around the heap, not necessarily in a contiguous location. So reading those objects off the heap is often going to be very slow unless it's in a contiguous location. Is it a host environment object, or is the object living in Lua, or is the object living in the C++ side of things? And how do you transfer them across that barrier, right? Lots of ramifications for ease of use, correctness, and also performance, which we'll talk about a bit later. Okay, so here's a very common challenge. I want to load my actors. So you might have, for instance, a vector of actors. Pretty reasonable. A vector is going to allocate some space on the heap, and it's going to be contiguous, so it should be fairly efficient. And you might decide that, well, I loaded my actors in this order. Is this sorted by name or not? Okay, well, if a certain feature of your engine requires this, then you're going to need to sort them by their name. But you want the original ordering as well, because you might not need that for a different feature of your engine. So one thing you could do is you could create another array, except this one isn't just the actors in your scene. This is those actors sorted by their name. You might then say, well, I want my actors, but I want them grouped by their location. In fact, I want to have a map. Something like an unordered map with a pair key giving me a list of actors, right? So why would you want this? Well, I think some of you did this in homework 3, right? You basically want the ability to index. What is my X position? What is my Y position? And then get a vector, a list of all the things at 13.9. Or I want to very quickly in O of 1 time look up all the things at 17.2. It's a very, very common accelerating data structure, for instance, for checking collision detection. When you have a grid world, you can do this, and it's very fast, okay? But I have a question for you. How many copies of the player actor exist right now? We started with our database where we loaded in all of these actors, but then we created 2 accelerating data structures. And now we have a massive problem on our hands, a huge one. that will wreck you, and has wrecked quite a few students in this course actually, which is why this lecture exists. How many players exist? 3. 3 of them exist, and if you don't see them, here they are. We have a massive, massive problem. When we created these 2 accelerating data structures after we loaded our first one, we created them by making copies of our existing actors. Okay? Not references, but copies. That is a massive problem. What is the problem? If I want to, for instance, mark the player object as being in a new location, right? Its X and Y are going to advance. And I grab my player out of this data structure and update it. This player object is now in a different location than this one and this one, right? We now no longer have any definitive location for the player, and you have a massive bug. Some parts of your code might use this player and think it's at one location, 1915. Other parts of your code base might use this player and think it's at 1319. And you're going to be very, very confused. 3 separate copies, okay? Lots and lots of problems. So this is a violation of DRY, which stands for don't repeat yourself. This is a very common principle, not just in programming, but in any organization where information is flowing fast. I believe this was actually originally a military principle, where you might give an order to, some department or some troops, but then you might rescind that order and try and give a different one. And there are now multiple copies of orders out there, and the troops don't know which one you mean, right? Which one to follow. And this is a big problem. So don't repeat yourself, it stands for. DRY, D-R-Y, don't repeat yourself. Every piece of knowledge should have a single, unambiguous, and authoritative representation within a system. i.e., stop copying and pasting stuff because that creates copies, and then if one of them changes, now you don't know which copy to check to get the truth. You want one source of truth. This also comes down to copy and paste bugs. Has anyone ever had a copy and paste bug? This is when you have some logic you really like and you want to reuse it. You should put it into a function. But instead, you're going to just copy and paste the logic here in your codebase and here in your codebase and here. And over here is pretty much the same logic, and up here is pretty much the same logic. Then later, you discover, oops, my original logic had a bug. So you update it here, and you remember to update it up here. Oops, you forgot about here and here. So now you're going to spend a few hours chasing down that bug, and you're eventually going to remember, oops, I fixed it in 3 places, but there were 2 more I didn't fix it in, okay? Copy and paste bug. You want to put it into a function that creates a single source of truth for that logic. You want to fix the bug, you fix it in the function, and you fix it every place. Very nice. Okay, improve maintainability, prevent memory chaos, and it reduces copy and paste bugs. One of your best principles for the quality of a code base. Avoid making multiple copies of any important object. This is kind of a takeaway here. And solutions to this problem, okay, don't copy objects, copy pointers, okay, references, basically. Here's one way to solve the problem. You have your original array of actors. Your database, this is your source of truth. And you have your 6 actors here. These are the actual objects. Now, if you want another view into this database, you can create an accelerating data structure. Okay, so what we're going to do is look at this. We're going to have a vector, but not of actors. We're going to have a vector of actor pointers. And these pointers are going to be a secondary way to look at this group of actors. So what we can do here is we can run through and sort these, and we can have the references instead. So if you roll down this array right here, right, our first actor, sorted by name, is going to be the player, right? Makes sense. But then we're going to get Spartan 1, Spartan 2, right? Spartan 3. The numeral at the end is causing this particular sorting order. And so now we have this nice view, this accelerating data structure, And we don't have to worry about making any copies. So we haven't made any copies of the original objects. We are just referencing those original objects in a different order, okay? We have a layer of indirection, which does slow down your code a tiny bit, but not very much, it turns out. And it's well worth the convenience and avoiding the violation of dry. So we're maintaining pointers in here. It is dry and fairly lightweight. Pointers are very small. You know how big they are? You recall? It actually, it depends what machine you're on. I think most pointers are like a double, though, on most modern machines. Is that right? Am I getting that wrong? No? I think it's like a double or something like that. 4 bytes and an int, so 8 bytes, I think. Yeah, 8 bytes. It's not too bad, all right? And you can copy around and mess with them because they themselves don't have any value. They just point and refer to something that does have value. So you can mess with them as much as you want. If you want to get these, you can use code that looks like this. Actor star, actor pointer, player actor equals scene actors 5. That's going to be this one right here, and you can use the and sign to grab the address, and you put the address into a pointer, and there you go, okay? And so now we have a pointer to the player as well. So we're building up these convenient pointers. There are some things that can go very wrong here, which we'll talk about in just a sec. But the important part is that only one copy of each actor actually exists under the hood. So things don't get messed up as easily. If you want to, here's some sample code. Let's take a look at it. I like to name my sources of truth as DBs, databases. And you can name them whatever you want. But this original vector of actors I refer to as kind of our dry data, our database. And what we're going to do here, and actually, if you look at my game engine structure, you've got like scene database, actor template database, you've got component database, you've got image database. The image database is where all the images are going to live, the actual images loaded into memory. And then if we want to mess with the images, we'll have like an array of pointers or a map of pointers or something like that to organize them more efficiently. But we want to avoid making those copies. If you look over here, we can create this convenience data structure or an accelerating data structure, vector of actor star, even actors. And we create this even actors array by iterating through our actual database one by one. We check if that actor is even numbered. Then if it is even numbered, we push a pointer to that actor into our even actors array. And now we have this even actors array. We can iterate through. We can do whatever we want with it to just access the even actors very quickly. So if you imagine, if certain actors have certain properties, then you might want to organize them a bit so that you can do operations only on those particular actors. And you can then iterate through and you get this output just like this. A question to you. What happens if we have this database of all the actual actor objects, not pointers, the actual real McCoy, okay? The actual things. And we create these accelerating data structures like the even actors array of pointers. And then down here, we sort the original database. We sort it. What happens?
Pointers invalidated now, so.
Yep, chaos. Absolute chaos. The pointers are invalidated. All right? Well, actually, hold on a second. What happens to the original data if we sort the even actors vector? Nothing happens if we sort the even actors vector. But what happens if we sort the actors vector? Boom, we're dead. Okay? We're absolutely annihilated. Pointer invalidation, total chaos. All right? Things are going to go crazy. You're going to be reverting that as fast as you can. Sprint to GitHub. All right? Okay, so watch this. Because actually, I think this is a big question, a tough question on your quiz coming up. All right? So pay attention to this one. We've got our scene actors, and we have a data structure that helps us know which actors are in particular grid locations. I mean, this is what you already saw before, okay? Here is the data structure right now. Okay, it's called location to actors. You provide the location, you get the actors. Okay, location to actors allows us to find all the actors at cell 17-2 in O of 1 time, which is very, very nice for us. However, I want you to imagine that you alter the scene actors array. Like you remove it, you remove some stuff, you sort that array, you do something to it, okay? So let's say that you sort by name, and then you remove Spartan 4 and Spartan 5. What is this array going to look like? You sort by name, and then you remove Spartan 4 and 5. What does this array, our scene actors array, look like after we do this? Picture it in your head, and here it is. It looks like this, okay? We've gone from this, everything is perfect, everything is right in the world, to this. And we are very scared right now, okay? We're terrified right now. Notice our scene actors array has changed. Objects have moved in memory, okay? And our pointers in our accelerating data structure are now pointing to things they were never ever meant to point to, okay? Notice some really crazy, like demonic things that have occurred, okay? Just because we sorted this original array and removed a couple things, all right, our player has actually changed position. Can you believe it? All right, our player, a vector, which originally, hold on a second, our player was in 1319. See it? But after this change, our player is now in 17-2. Oh my goodness. Okay? So crazy things are happening, and this is a telltale sign that you've had some sort of pointer invalidation or memory corruption bug. Okay? And so you also have some dangling pointers in here, where if you go look up, hey, is there anything in 17-2? You're going to find the player, which is not in 17-2, should not be there. You're going to find Spartan 1, which should also not be in 17-2. And then you're going to find null. Yeah, null is kind of chilling in 17-2. Okay, dangling pointer. Actually, it's not going to read as null, the 0 pointer. It's going to read as this address, but there's nothing there. So if you dereference it, it's going to blow up and explode, and you'll crash. Okay? So this is not good. This is kind of a common bug. Hopefully, you avoid it now, but it's a very scary bug. If I see a bug like this, usually what I do is I revert my changes. Okay, get back to a pleasant state, and then I recreate my work much more carefully. So, what can we do to fix this? Any ideas? If I don't call on you, if I look at you and don't call on you, it's because I'm like trying to get some other hands. But rock and roll, you got it. Go for it.
Yeah, definitely don't sort any kind of database vector. And
yeah.
Maybe you could have a variable inside of that. It's not like a variable. Yeah, like a variable that says deleted or not, and then you need to actually make a bunch of different changes to all your different data.
Yeah, so there's some efficiency things you can try. The big one is you don't really want to go messing with your source of truth. You don't really want to alter it too much once it has been changed, because that source of truth now has a lot of data structures that have been built up based on it. And if you sort it, if you mess with it, you're kind of sweeping the rug out from under those data structures. They no longer make sense. All those pointers are now invalidated, and that's quite bad. So avoid sorting. But there's actually a kind of more common issue that can happen that's a lot more innocent and it's an easier mistake to make. Let's see here. Tell me this, what happens if you build up this database, okay? You got this database and everything is fine. You then build some accelerating data structures that reference things in this database, and that's also fine. We're all good so far. But then you load additional actors into your vector. You load more actors. We found some more actors, or GameObject.instantiate, we can add more at runtime. What happens to this vector as we keep adding things to it? Yes?
It's going to grow, so it's going to move in memory.
Bingo! All right, it's going to grow, and for a little bit that might be fine. But eventually, the amount of memory that has been reserved for this vector, we're going to exceed it, right? We keep adding things to this vector, and maybe the vector has been sized, it's been allocated enough memory for like 8 objects. But we go to put that 9th object in, and it's like, oh no, we don't have enough space. So what's going to happen? This vector and all this content is going to be moved to a new location on the heap that has more space for it. And those objects are going to be copied in to recreate the vector. But there's a big problem. You moved them. They're at a different location now. All the objects are in different locations, so all of these pointers are now dangling. And you, by just innocently adding some objects to the container, have now annihilated all of your accelerating data structures. Not good, okay? Very nasty. Fortunately, on homework 4 and 5 and 6, you can't add additional actors mid-scene. In homework 7, that changes, and you can add more actors mid-scene. But you don't have to worry about that kind of invalidation happening for a little while. Okay, so how do you deal with this pointer invalidation? Sometimes, if you need to add things or alter that original database, you can go and invalidate all of those accelerating data structures. You can rebuild them. That's something you might do during a loading screen between maps or loading screen between scenes. Okay? You can go back in, load up a bunch of new actors or add more in, and now you can recreate those accelerating data structures. It's a loading screen, so no one cares if it takes a few moments. And then you're good again, right? Everything is right with the world. Yep. Sometimes you can just avoid invalidating that stuff altogether. Yes, a big warning, as you add elements to containers, often that container will need to resize, i.e. it will need to find a location on the heap that has more memory for it to get. And that means everything is going to move, which means you invalidate everything. Okay, be very careful. You can sometimes use .reserve. .reserve is going to tell the container, hey, we know you're going to need a lot of elements, however many you provide. You can provide a number here, and you can say, hey, I know I'm going to need 50 elements, so give me space on the heap with 50, all right? Enough space for 50 elements. And that will prevent it from resizing as you build up toward 50. If you go over 50, it's going to resize, and it's going to move on the heap, so don't do that. Another thing you can do is, in general, you can delay the creation of your accelerating data structures until you have all the actors loaded into your database. At that point, probably not going to move. You can build stuff on top of that without worrying too much. So a question is it possible for our engine to add additional actors mid-scene? The answer is no on homeworks 3, 4, 5, and 6. On homework 7, the answer is yes. And you'll have to account for that and figure out a way to deal with this. Okay? But this is yet another instance where if we can add restrictions to our game design, to our engine, it simplifies the engine's life a lot and can allow us to optimize. If you say to the game designer, hey, you're not allowed to add actors unless we're loading in the scene initially, then we don't have to worry so much about this, right? Not a big deal. As soon as the game designer can have more actors spawn, then you need a more creative solution. So, interesting to think about. If chaos breaks out for you and suddenly just things that used to be working are no longer working and nothing makes sense to you, I recommend going back and discarding your changes on GitHub. Only make a commit when you're feeling pretty good about your code base. That makes it super easy to discard changes that are causing chaos, and you can build back up. All right? Don't feel like it's lost time. It's a very good exercise to implement something once. It's a bad implementation. Implement it a second time, it'll be much better. All right? almost a guarantee. You'll also learn a lot more that way. Okay, how can you study and kind of experiment with this stuff, right? The fact that you adding stuff to a container will move the container in memory is one of those C++ things that surprises a lot of people. You can learn a lot about C++ just by experimenting and discovering these things yourself. You can Google CPP compiler online, and you'll find a lot of very nice, very fast compilers that will just work out of the box. And you can do really simple experiments like this one that I showed you earlier. And you can learn these lessons yourself and get a good feel for things. A good way to memorize something is to go program it yourself and poke it and prod it in different ways to see what actually happens. Once you can predict what's going to happen, your mental model is now strong enough to carry you into a quiz or an exam or onto the projects. So run experiments and have fun, okay? Anyone have any questions or comments? Yes, in the back.
I was wondering with the previous example, do you want to avoid using like a unique pointer for the database just so you can like manually control like when the actual like rebuild happens rather than just letting it handle its own like deconstruction and stuff like that?
So are you asking like, do you want to avoid smart pointers?
Yeah, using like a unique pointer for like, the database, so then like if it needs to resize itself, those like memory locations don't get messed up.
I don't think so. In this course, I didn't use a ton of unique pointer, but you can. Shared pointer is what tends to be used a bit more commonly. But at least in these first few homeworks, there isn't a whole lot of memory management to actually be done. I think one of the most important things, and one of the reasons that I tend to make these database classes, is that the database itself is responsible for loading in the actors dynamically and then making sure they're taken care of when they need to be deleted, like when a new scene comes in. So in that event, you don't really need to care very much about the smart pointers or what the smart pointers are going to give you. I don't think is all that important. One thing that's kind of interesting about smart pointers, when you're using something like shared pointer, you're kind of replicating a kind of managed environment situation, like what you see in C# or Java or Python or something like that. With a shared pointer, what's going to happen is as you are kind of collecting and creating more shared pointers, the shared pointer is going to keep track of how many references to a particular like object or memory location exist. And when it is, when all of those shared pointer references kind of go out of scope, it's going to make that deletion happen for you, which is kind of sort of similar to how like a garbage collector works, except it'll happen immediately in C++ instead of waiting for a garbage collector to trigger like sometime later. But in any case, I don't use a ton of unique pointers. I don't use a ton of shared pointers. I don't think the memory management in this course is that tricky. And in particular, the autograder doesn't really care so long as it's not affecting your performance. So you can experiment and find out what style is going to feel nice for you. Yeah, okay. Any other questions? Hopefully that answered your question. If it didn't, talk to me in office hours, which is coming up. Okay, I think, let me take a look really quickly. I think that is all that I have for you today. Let me see here. Oh, I want to show you a couple interesting things. So we talked a little bit about your coding style and structure. I don't think you need to have a big object-oriented setup for this game engine project. A lot of game engines are actually not written in C++, they're written in C, which doesn't have kind of explicit support for classes. You can kind of hack them in. But I definitely recommend that you try and organize your logic into different files, right? Especially when it comes to resources. A very common pattern is you have some sort of resource you want to manage and load and manage access to, manage the memory allocation for, like images, loading them from disk, okay? Scenes, stuff like that. Create like a class that manages and handles images, caching them, loading them, doling out pointers to them, cleaning them up when your images are no longer needed. I want to show you, however, that horrific coding standards can result in disastrous games like Yandere Sim. But there was a game called Thumper that was actually very successful. It took 7 years to make, which may be a result of the unique coding practices this team used. But Thumper was made, I think, in C++, and it was made in only 3 to 4 files. It used no classes and only a small handful of functions. It was a very kind of, kind of traditionally made game. I don't know if it was a game that felt like it was developed with a very kind of 80s or 90s era coding style. But you can go through this interview. I remember being here in person. I'm behind the camera, I think. The team talks about how, especially because they only had one programmer on the team, it just didn't really affect them very much to code basically everything with just minimal usage of fancy object-oriented constructs. CPU optimization, they talk about optimization, aftermath. Somewhere in there, they talk about the coding styles and their architecture. But anyway, I would encourage you to check it out if you're curious about how pathological coding styles can still work if you are ready to go deal with them, if they're right for you. But I hope you will not do that experiment, and I hope you will try and at least break things up in a sensible way, okay? If you want ideas on how to break things up, come talk to me, okay? All right. Any final questions? Okay. I think, personally, the magic in this course and most of my courses are in the assignments and then the autograder and the feedback you get. I think I'm going to add some more content on the topic of smart pointers to this lecture in the future, but I think we'll talk about them a little bit more as it comes up. I've also I'm curious on what you think. I've been thinking about adding a metric, memory management metric, i.e. memory leak detection to the autograder, so that you not only need to perform very fast, but you need to make sure you prevent memory leaks as well to get full credit on the test cases. I think it'd be a good idea. But there's kind of an interesting again, pathological logic to what is the ultimate memory cleanup system, the ultimate kind of memory cleanup technique. If you don't manage your memory very effectively, something will eventually. Yes?
Turn it off and on.
Turn off and on. You're referring to a technique that the Xbox was able to use, where once memory got so consumed and there was none left, you could actually turn off the software and turn off the Xbox while keeping it displaying an image. So you could trick the user while the Xbox rebooted to free up memory again. That was one way of fixing memory leaks. One way to deal with memory leaks is to simply have the operating system kill your program. The operating system will clean up your memory for you, and then you can run again. Ideally, that doesn't happen, but your memory will be freed when the program concludes in any event. But I think maybe in the future, we'll have the auto grader kind of try and detect this and grade you on that. But personally, I don't think memory is all that tricky in the game engine that we're making. Right? It's not doing anything particularly crazy. You just need to remember to free up stuff if you need to. But that's where your database classes come in, right? So your image database is going to be responsible for loading in the images and detecting when they're no longer necessary and caching them. And when they're no longer necessary, you can get rid of them. And as long as the image database is the one handling all of this, you're fine. One very important concept in memory management is ownership. This isn't in the slides, but I think it should be. I think I'm going to add them. Ownership. Who is managing the memory that has been allocated? So I think an example here, okay? Here's an example. When you load these actors into this scene actors array, these actors are going onto the heap, okay? They are in dynamically allocated memory. You are not using that terrifying new keyword. How many of you feel a little fear in your heart when you use that new keyword? You see it, right? You're like, oh no, I'm dealing with pointers, that's bad enough. Now I'm also dealing with memory that I'm going to have to remember to free or have a memory leak. Which could turn into bugs, could turn into a performance issue. Well, when you use a vector, your vector container is calling new on your behalf. And when this vector, the scene actors variable, goes out of scope, the vector in its destructor is going to free the memory for you. In other words, this container is responsible for all of these actors. It owns these actors. It is going to manage the memory of these actors on your behalf. You don't have to worry about it. What happens if you are very paranoid and you decide that, oh, I don't know, Spartan 4, I'm going to deallocate, I'm going to free Spartan 4, free the memory of Spartan 4. And you do that like in the middle of gameplay. The container is still here. It is still managing Spartan 4, but you have decided to free and release the memory where Spartan 4 is located. What's going to happen? Like at the very least, when the program goes to end, or when you go to like when scene actors goes out of scope, what's going to happen? Scene actors is going to try and do something. Yes?
It's going to try to like deallocate itself, or you're going to have like a weird gap in memory.
Yeah, so scene actors is responsible. It's the owner of this memory. So it tries to deallocate Spartan 1 and it succeeds. Spartan 2, Spartan 3. Oops. Spartan 4 has already been deallocated by you, someone else, some other code somewhere else in the code base. It's going to double deallocate Spartan 4, which could cause a crash. Okay? And it's going to be kind of confusing, right? Because it's going to happen very delayed. You're going to have to remember that you accidentally deallocated this memory, and then later the vector came in and tried to do it, and it was already done, so it explodes. Okay? So that's the concept of ownership. I think it's maybe the most important thing for memory in this particular project you're making. When you allocate something, just make sure that you have one system or one entity that is handling that memory and nothing else is going to try and free it. Okay? In this case, you have a container that's going to handle that for you. Very, very, very nice. And in the case of like the image database, you have an image DB that's going to be allocating memory for images you load in. And that image DB should be the only class that is going to be deallocating that stuff. No one else should be doing that. You want to be a little bit careful with smart pointers because smart pointers are going to try and deallocate that memory as well. They are owning that data. If you then try and deallocate it yourself, well, the smart pointer already did it for you, and now you explode, okay? So you want to be very careful. When you create something like a unique pointer, that unique pointer is going to kind of be the owner of that piece of data, and it's going to handle the allocation and the deallocation. And you want to make sure that you don't accidentally handle that yourself. So I don't think it's a very complex topic, but it's very important. Okay, it's a good way that memory can get very spicy for you. Okay, any questions or comments? All right. Good luck. Have fun. I want to point out something really quickly too. The first part of this assignment, you can find the assignment spec right here, is not going to be C++ programming. Did you know that you can actually alter the memory of any game that you are running at any time? Well, you know, I don't think I have enough time to do this. But I have a lecture called Introduction to Modding and Hacking and Cheat Codes, where we open up Street Fighter 4 and we actually attach to the process using a program called, do I have it? Cheat Engine. There we go. And Cheat Engine is going to allow us to attach to the process, which I can kind of do right now. I'm going to attach to like Firefox instead, okay? And I can click this button called first scan. Oh, it's not happy. Oh, first scan, I need to provide a value. I want all values that are between, I don't know, 0 and 1,000. Let's say I'm looking for the health value for my fighter in Street Fighter 4. I do a scan for all values between 0 and 1,000 that are 4 bytes, and I can look for all these, and look at that. I found 33 million addresses in my memory that have this value. Some of them are 1, some of them are 0, a lot of them are 0, some of them are 342, 425. What you can then do is you can kind of whittle down these addresses to figure out which one is probably your health bar. It's got to be somewhere in your RAM, right? And you can do things like, oh, I want to, you play the game a bit more and you take some damage. So then you say, oh, my health went down. So I want to keep all the addresses that have a decreased value from the last time I scanned. Next scan, I'm down from 33 million addresses to 44,000. And you can keep whittling away until you've got only a few addresses left. And then you can go in, you can actually edit the number at those addresses. In fact, you can go in and you can actually browse the assembly, I think. Okay, find out what writes to this address. Yeah, attach the debugger. Okay, we found some people writing. I can double click on it and I can actually see the assembly code. And I think I can go in and I can edit the assembly code. I can no-op it, I can write new assembly, and I can experiment to make cheat codes. Okay? You are going to do this. You're going to do this with the CrySearch program, which is available on all these computers, I think. And you are going to have to, let me see here. You're going to have to find out where your ring counter is in a particular Sonic fan game. And let me show you the images that people are posting right now. Let me see if I can open that up. Let's go to, here we are. Let's go to exhibition. I'm going to give you oh my goodness. I'm going to give you a little hint. This fan game does not have 65,000 plus rings in it. Okay? And yet, you can get in there, and this isn't just a UI thing. This is the actual integer in memory that tells you how much rings you have. A hint, if you go and put a big number like 900 into your ring count, and then you go take damage, what happens in a Sonic game when you take damage? Anyone know?
Do you drop rings?
Yeah, you drop your rings. So I'll tell you, if you put 900 in here by editing RAM, and then you go take damage, it's going to take like 30 seconds. Your computer's going to freeze up, and then like 900 rings are going to spawn and go flying all at the same time. It is beautiful, all right? Anyway, so this is what modding sometimes looks like, especially if we don't get access as a community to the source code. We have to go kind of disassemble the game, and we have to work backwards to figure out where important things are in memory. And that's how we can create cheat codes and create frameworks that then allow other people to develop in languages like Lua instead of messing with the assembly. All right? It's a very powerful feeling, and I think many people, how many of you have never edited your RAM before? You haven't used something like Cheat Engine or CrySearch? Quite a few of you have. That's really impressive. You've done the Cheat Engine and CrySearch for fun? If you haven't, you might not realize how much power you really have over software that is running on your processor in your RAM sticks. Okay, they belong to you. You can see what they are doing. You can find the ones and zeros in there, and you can mess with them if you want. There are techniques for figuring out where fun stuff is in that mess of zeros and ones. And so you're going to get to do that this week. I hope you have fun, enjoy it, and we will, we'll see you next time. We'll see you on Wednesday, okay? See you then. I will be around for 2 hours from 6 to 8 p.m. tonight. If you want to get started, let me know, and we will knock out homework 4. Okay, everyone watching online, good to see you. Thank you for joining us, and we will see you next time. Bye-bye.